Okay, kids, we're going to look at the Hoffmann Apparatus now, which is a really cool machine right over here. The Hoffmann Apparatus is this orange piece of plastic with this setup of glass tubes. Into the top, I put water, and the water runs down the center, and then it splits and goes back up these side tubes. At the very bottom, you can see there's two corks. And inside those corks is a little glass tube with a piece of platinum metal. The platinum metal is connected through that glass tube to a piece of copper on the outside. This machine here is plugged into the wall, and out of the walls of American sockets comes what's called alternating current, and the electricity pushes and pulls and pushes and pulls and pushes and pulls at a certain rate, certain hertz, 60 cycles per second. This green machine is sort of old-fashioned. It's probably as old as I am, but it converts the alternating current that comes through the wire into what's called a direct current. So it basically turns the electricity in the wall into like a big battery. The battery is going to come out this white wire and go in on this side, and then the electricity is going to come back out the green wire in what's called a direct current. The direct current means it comes out on one side and comes back the other. In this setup, there's just water, and there is a little bit of acid put in there because water by itself will not conduct electricity. So the acid will provide some ions to make it an electrolyte. The acid is mostly water. It's just some extra ions. It has no bearing on what's going on other than it allows the water to conduct electricity. Now, what's really cool, I'm actually going to turn this off right now. What's really cool is that this side on, well, I don't know which side left or right is, but over here, there's a lot of gas, and over here, there's less gas. And if we look at the numbers, this is at 22 mLs, and this actually is at 44 mLs. There's twice as much gas over here as there is over here. Now think about it. Why would there be twice as much gas on one side and only half as much on the other? It's a Let's see what we got here. It's a 2-to-1 ratio. What's the formula for water? H2O, 2-to-1. When we decompose water, we're going to get twice as many moles of hydrogen as we are going to get of oxygen. So these two gases should be hydrogen and oxygen. Now, how would we know if they're hydrogen or oxygen? Well, there's a test. And in order to do the test, I have to start the Bunsen burner. I need like 5 to 10 seconds. I need to get some fire. I'm coming. I need to get some fire. So on this side, I think there's hydrogen. So what I'm going to do is I'm going to let the gas come out and into this test tube. Now, hydrogen gas, if it is hydrogen gas, is lighter than air, and it should stay in the top of the tube. Now, this is the test for hydrogen gas. Did you hear that cute little toot? That cute little toot. What? Here's another test. Ready? This is fire burning in the air. See how it went out? The carbon dioxide that comes out of my breath puts the fire out. But the toot, that actually is called the synthesis of water. The hydrogen in the tube combines rapidly with the oxygen in the air, and there's not too much. Remember the first day with the big balloon? It went boom. This was just a little friendly toot of the horn. Now, there's another test for oxygen, and I got to get some more fire. Give me a second. Now, the test for oxygen is different. We're going to start with the fire. I'm going to put it out. So it's just what's called a glowing splint. And then I'm going to put it in the tube. Ready? And I'm going to stick it in here. And the fire comes back on. The reason that worked is because there's so much more oxygen in the tube. No carbon dioxide. There's so much more oxygen in the tube compared to out here. In the air, there's about 18, 17% oxygen. In this tube, there's about 99% oxygen. So when I fill up the test tube, it's almost pure oxygen. So when I put the stick that's not quite on fire anymore in there, there's so much more oxygen able to bang into that piece of wood that it's able to kickstart that reaction again. So the test for hydrogen gas, if you touch the hydrogen gas with a flame, it explodes. Now, if there's just a little in a little test tube, it makes a toot sound. The test for oxygen is if you take a piece of wood that's glowing hot, but not quite on fire, and you put it into that gas, it will catch on fire again because there's so much more oxygen in there. It allows the reaction to go quicker than it could normally in the air. There's more connection between oxygen and the wood. And the final test for carbon dioxide, when you put a fire into carbon dioxide, the flame goes out. And the reason that is in order for the flame to keep going, the burning wood has to keep touching oxygen in sufficient amount. The carbon dioxide literally gets in the way. Kind of like if you want to meet somebody, but there's 100 people around them. It's very hard to get in there. So if you have to meet that person to make a connection, those other people get in the way. In this case, the carbon dioxide gets in the way and insufficient oxygen touches the wood and the fire just conks out. All right, this is called a Hoffmann apparatus. And what it does is it uses the electricity to decompose water. It decomposes it into hydrogen and oxygen in a 2-to-1 ratio because H2O is in a 2-to-1 ratio. And we can test for the individual gases. Hoffmann apparatus is really cool. All right, there you go.